Okay, very now 5.5. We are on page 1. We're going to learn how to use substitution method. Substitution method is solving integrals. So this method says if you have the integral of f of g of x, so if you have composition of two functions, and at the same time you have the derivative of g prime. G prime is available here, the derivative of the function inside. So if you think about it, it's actually the inverse operation of chain rule. Then this integral is equal to, here you can take g as u, then you have du. This is equal to the integral of f of a variable like u, and instead of g prime dx, you can simplify that to du. U substitution. You take u to be g prime g of x and du g prime dx. Substitution method. Let us go over one quick example to feel comfortable about this method. Example. Which one? Question says, find the integral of x to the third cosine of x to the fourth plus 2 dx. Okay. So let me write x to the third next to dx for you. Okay, perfect. So your function f is cosine. The inside function is gx equals to x to the fourth plus 2. So gx is equal to x to the fourth plus 2. Do you have g prime x dx inside the integral? You have to calculate g prime. G prime of x is equal to 4 x to the third, and the derivative of constant is 0, and since you took the derivative with respect to variable x, it copied down dx next to it. Very well. As you can see, you have variable x raised to exponent 3. Some part of the derivative of function g is inside the integral. So x cubed dx is equal to g prime of x over 4. So if I multiply this by 4 and at the same time divide by 4, I have my g prime of x. So this integral is actually a 4 integral cosine x to the 4 plus 2 times 4 x cubed dx. Take a look at the substitution method. I have the integral, my f is cosine, my g is x4 plus 2, and I have g prime of x dx next to it. I can use u sub a new variable like u to simplify this integral. So u sub Use substitution method says this can be written as a 4 integral cosine u, and this guy is du. Very well. We have a nice integral, and we already know that the integral of cosine is nothing but sine. We already know that. This is a 4 sine u plus constant of integration. Note that your original integral has variable x, so your final answer must have variable x, not u. So what was u? U was x to the 4 plus 2. You write this guy back here. A 4 sine of x to the 4 plus 2 plus constant of integration. This method is called U substitution or just substitution. Okay, perfect. So let me write the general things that you need for U sub method here for you. So in general, we can use U sub method for the following. Substitution method. So if you have integral of sine of a function, whatever it is. So let me write this guy here as sine of u. And you have du, you can use u sub. So in general, if you have a function like box, you must have the derivative of box next to sine. Then you can use u sub. If it's cosine, the same. Integral of cosine of your box, you must have the derivative of that box next to cosine to be able to use u sub method. It must be there, otherwise you cannot use u sub method. If you have integral of, for example, radical, integral of radical of a box, the quantity inside your radical, you must have the derivative of the box next to it. If you have exponential function, you have to look at the power, the exponent. E raised to a box. So this is your box, this is the function, this is your g, and the derivative must be next to dx. So you look at your power, you look at your exponent. What else? This one is good as well. If you have a quotient, on the denominator, you have your box. On your numerator, you have the derivative dx. So these are the general formats that you can apply substitution method to solve your integral. Let's go over another example. We are still on page 1. Another example for you. Example. Very well. Here you have the integral of dx times x divided by square root of 1 minus 4x squared. Very well. I have a radical. I look at the quantity inside the radical. So let g of x be 1 minus 4x squared. When you have radical, look at the quantity inside radical. 1 minus 4x squared. Now check to see if you have the derivative of this function next to dx or not. The derivative of this function, the derivative of 1 is 0, the derivative of negative 4x squared is negative 8x times dx. So this is the derivative of this function. Do I have negative 8x dx here on the numerator? Do I have negative 8 times x next to dx? I have x. It has minus 8 multiplied by x. Since it's just a number, it's not a variable, we can quickly multiply x by negative 8 and divide by negative 8 and create this negative 8 on the numerator and actually apply substitution method. So your integral is now equals to, let us multiply by minus 8. I'm multiplying my integral by minus 8, and at the same time I'm dividing that by minus 8, so it balances this multiplication operation. Negative 8 times x, it has dx, and on the denominator I have square root of 1 minus 4x squared. Now you can use sub method. This is equal to minus 1 over 8, the integral of du divided by square root of u. This is your u, and this is the u. Wherever I see 1 minus 4x squared, I write u. Wherever I see negative 8x dx, I write du. This integral is not very hard to evaluate. Take a look at this. Here you have integral of du over square root of u. Let us solve. This is equal to minus 1 over 8 integral of du divided by u raised to a half, which is minus 1 over 8, the integral of u to negative 1 over 2 du. I have exponent, negative a half. This is equal to minus 1 over 8 u raised to negative a half plus 1 divided by negative a half plus 1. Don't forget the constant of integration. This is equal to negative 1 over 8 u raised to positive a half divided by positive a half. If you add these two numbers, a half plus constant of integration. You can flip to write it next to u to a half, so you get negative 2 over 8 square root of u plus c, which is equal to negative 4 square root of, what was u? U was 1 minus 4x squared, 1 minus 4x squared plus constant of integration. Okay, so let's explain this one more time. This example says you have integral of e to 5x dx. So what's the difference between this and this? integral of e to the x dx. So the integral of e to exponent x is equal to e to x plus c. If you have the integral of e to t, one variable, not a function, dt is e to t plus c. If you have the integral of e to u, du is eu plus c. Here you don't have a variable. It is 5 times the variable. So since you have e raised to a function, in this case here you have a linear function, you say that, okay, if I take gx to be 5x, the derivative of g is 5 dx. So it's not just one variable, it is 5 times the variable. Since I don't have 5 next to dx, I can multiply and divide. Then I can apply u sub method. So your integral is now 1 over 5 e to 5x, 5 times dx. I just multiply this by 5 and divide by 5 because I need 5 dx here to apply u sub method. So your gx, your 5x, is just a new variable like u, and 5 dx is du. Wherever you see 5x, you write u. Wherever you see 5 dx, you write du. You write the integral in a nicer format that you know how to find that integral. The integral of e to u du is eu plus c. You have a fifth in front of it, a fifth e to the u plus c, but again, since our original integral has variable x, the final answer must be in x. This is 1 over 5 e to 5x plus c. We are on page 2, still on page 2. Now we're going to use u sub method to find the definite integral, evaluate our integral. So in this example, here you have the integral 0 to 4 square root of 2x plus 1 dx. Okay, perfect. So look at the general format. Here we have the radical. Inside the radical, we have a function. If we have the derivative of the function next to dx, we can apply u sub method. So suppose gx is equal to the quantity inside radical. Guys, do not take the whole radical inside the radical. 2x plus 1. G prime, the derivative, is equal to the derivative of 2x is 2, the derivative of 1 is 0, so it is 2 dx. Very well. We're lucky. It's just a number. It doesn't have any variable next to it. So if I multiply the integral by 2 and divide by 2, I can create g prime and apply the u sub method. Okay, I'm going to multiply this by 2 and at the same time divide by 2. This is equal to u and this is equal to d. So your integral is a half integral. Guys, we are changing x into u. We cannot have 0 and 4. This is the integral of u du. First, calculate this integral, write it in x, then use 0 and 4. This is equal to a half integral u to a half du. This is equal to a half u to a half plus 1 divided by a half plus 1, which is equal to a half u2 3/2 over 3/2. You can flip this to get a half, 2 terms. u2 3/2. You can cancel out 2 and 2. This is equal to a third. Now, what was u? U was 2x plus 1. So I'm going to write down 2x plus 1 instead of u raised to 3/2. And then evaluate the integral when x is 4, then 0. 4 to 0. It must be in variable x, so you can use lower limit and upper limit for x. If it's u, you're not allowed to use 0 and 4. You have to change those. Very well. Here you have a third. 2 times 4 plus 1 raised to 3/2 minus a third. 2 times 0 plus 1 raised to 3/2, which is equal to a third. 9 raised to 3/2 minus a third. 1 raised to 3/2. This is equal to, so here you have 9. 9 is 3 squared. 3 raised to 3 is 27 over 3 minus a third. We get 26 over 3. And this is your final answer. So, what if we just want to use u instead of x to evaluate this integral? As I mentioned, you cannot use 0 and 4. So let me write it here for you. So your x is between 0 and 4. 2 times x, you multiply everything by 2. 2 times 0, 2 times x, 2 times 4. 2 times 0 is less than equals to 2 times x, less than equals to 2 times 4. This is 0, 2x, and 8. 2x plus 1. So what I'm doing, I'm creating this new variable, u. Now I add 1 to everything. Plus 1, plus 1, plus 1. 1 less than equals to 2x plus 1 less than equals to 9. 2x plus 1 is u. So your variable u ranges between 1 to 9. If you don't want to rewrite u in terms of x and you want to calculate this integral using variable u, your lower limit is 1, your upper limit is 9. So you have to change the lower limit and upper limit to be able to use variable u in calculation of the integral. You're on page 3. Okay, page 3, example. It says, okay, find the integral of dx over 3 minus 5x squared, and x ranges between 1 to 2. Very well. Remember the general format. They have something raised to an x on it. So let g of x be this quantity inside parentheses. Guys, you don't take the whole thing. You don't take the denominator itself. You take the quantity inside parentheses without x and 2. So this is 3 minus 5x. G prime of x is minus 5 dx. Okay, I have dx. I don't have this number. What I'm going to do, I'm going to multiply and divide by negative 5. So minus 5, negative 1 over 5. So this is u, this is d. So now I have negative 1/5 integral du over u squared, which is easy to find this integral. This is negative 1 over 5 integral of u raised to negative 2 du, which is negative 1 over 5. So we add 1 to the exponent. U to negative 2 plus 1, negative 2 plus 1, which is negative 1/5. U to negative 1 divided by negative 1. We can cancel out negative and negative. We get 1 over 5 times 1 over u. But what is u? U is 3 minus 5x. So this is 1/5. 1 over 3 minus 5x. And your x ranges between 1 to 2. x1, x2. Which is easy to calculate. Here I have 1/5, 1 over 5 times 1 divided by 3 minus 5 times 2 minus 1/5, 1 over 3 minus 5 times 1. Very well. My first fraction is 1 over 5 times 1 over 3 minus 10. Negative 7, okay, 1 over 5 times negative 1 over 7 minus 1 over 5 times negative 1/2. So this is equal to negative, so let us factor 1 over 5. It makes it easier for us. Negative 1 over 7 plus 1/2. If you take common denominator between these two, you get negative 2 plus 7, which is 5. 5 over 14, 1/5, times 5 over 14. You can cancel out 5 and 5. The outcome is equal to 1 over 14. So if you want to change the lower limit and upper limit, since you want to use u, it's like this. So your x is between 1 and 2. Your x is between 1 and 2. What about your u? First of all, u is 3 minus 5x. So you multiply everything by minus 5. When you multiply inequality by negative number, you have to flip the inequality. Negative 5, and negative 5. So now you have negative 5 times 1, which is minus 5. You have to flip the inequality greater than equals to. Now it is less than equal to minus 5x greater than equals to negative 10. Okay? This is very important. Multiplying an inequality by a negative number, you have to flip the inequality. Then it says 3 added to the rest of this. So we add 3, add 3, add 3. What do we get? You get minus 2. And this is 3 minus 5x, negative 7. So your u is in between negative 7 and minus 2. If you want to change the lower limit, and upper limit, and using u, this is the method that you have to use. Question says, calculate the integral 1 to e of ln of x dx divided by x. Perfect. So, you have ln function. Guys, when you have ln function and you want to use u sub, your u or g is always ln. So note, when you have ln function, let g be ln. Always, always. So, g of x is ln of x. What's the derivative of ln? The derivative of ln of x is 1 over x dx. Do I have 1 over x next to dx? Take a look at this. This integral can be written as the integral 1e ln of x times 1 over x times dx. Then you have dividing by x, the meaning of that is you have 1 over x multiplied by your numerator multiplied by another numerator, which in this case is dx. So since we have 1 over x next to dx, we can apply substitution method. So this guy is equal to integral, this is your u, and the whole thing here is du. We all know that how to find this integral. This is a half u raised to 1 plus 1. So this is a half u squared, but what is u? U is ln of x. This is a half ln of x raised to 2, and the range is between 1 and e. So you have a half ln of e raised to 2 minus a half ln of 1 raised to 2. ln of 1 is always 0. So since this guy is 0, 0 squared is 0, 0 times a half is 0. ln of e, they are opposite of each other, and it is always 1. 1 squared is 1. 1 times a half is a half. So this integral using substitution is a half.